Okay guys, we'll go ahead and get started with Chapter 2 lecture on JavaScript, and the title of it is Getting Started Fast with JavaScript, and that's one thing I will say is that this book does tend to move pretty rapid, and so you know, it's important to put in the work, and definitely want to recommend reading the chapters, listening to the lectures, doing the homework assignments, doing the lab. Probably more important than reading and listening to lectures is actually writing the code. That's ultimately how you're going to get comfortable with this, is by that hands-on practice. And so if we kind of look at the objectives here, you know, different ways that you can actually start to incorporate JavaScript into a document. We're going to talk about case sensitivity, semicolons, white space, you know, some rules for creating JavaScript identifiers and comments, how to comment out JavaScripts, lines of code, different data types in JavaScript. So if you've ever, you know, programmed before and you've worked with variables or data, then you've been probably exposed to data types, and you're going to find out JavaScript has data types. If you haven't ever really written a programming language before, this is a great first language to learn. And so it's totally fine if you've never written a line of a programming language before this class. This is a great first language. We'll go through some keywords like the let and the const keyword, what those do. Using JavaScript, we will start doing some math and some arithmetic, right? So we'll start problem solving using JavaScript and using some math. And so there's definitely some equations, some basic equations that we'll use to solve some problems. And then look at some of the different, you know, like a plus sign, how it could be used to actually add numbers, or what a fun term in JavaScript is concatenate strings. And so this plus operator, and how it can be used. And then there's some special characters in JavaScript, so \n. So lots of topics, lots of new methods that we'll get introduced to here, and then just some general syntax as far as, hey, I wanna write a method in JavaScript or a property in JavaScript, and how can I work with those things. And so, you know, maybe even before, you know, we get into all this, you know, I like to, you know, just kind of introduce the language. And so, you know, at a high level, I said many times in the first half of this class, you know, HTML. You know, HTML is for content. And so when you have, you know, text that you want to put on a web page, or you have an image that you want to put on the web page, or a video, or you know, whatever your content may be, content is really where HTML comes in, and structure. And so what's in the header, and what's in the footer, and what's in the aside, and what's in the main. You know, they have these what are called semantic tags that say, okay, this is the header tag, so probably this stuff should go up towards the top. And this is in the footer tag, so this probably should be towards the bottom. And so that's really what HTML is known for, content and structure. And then you got into CSS, and we learned a bunch about CSS, and really that's for the display of that content. So you want to change colors. Really the keyword in CSS is the style, so the styling of your content and how it looks. So you're talking about colors and font sizes and letter spacing and line spacing and positioning, where things are at on the page. And we got into responsive web design with CSS Flexbox. And you start positioning things around on the page responsively. And so if HTML is for content and structure, and then CSS is for the styling, JavaScript really adds interactivity for making interactive pages. And so one thing that's probably pretty obvious that you can do with JavaScript, because a lot of templates that if you downloaded like a Bootstrap template, a lot of them have image sliders. And so how an end user might interact with an image slider, they're all gonna maybe interact with them potentially differently, right? Click through them at a different pace, and that's just one way that a user can interact with the page. And so again, HTML is for content, CSS is for style. JavaScript, its big thing is to make interactive and dynamic pages. Dynamic meaning based on the way that I interact with the page, my experience, it could be a very different experience than you. For example, if I, purchase something on a page and I live in Illinois and then you live in Missouri, our shipping and handling might be calculated differently based on where we live. And so literally the information that we are looking at on the page is dynamic. It's changing. When you have HTML and CSS, for the most part, all that information is considered static, right? It's the same information every time. And so these are the big selling points of JavaScript. As far as the basics of JavaScript. We're going to learn to make our pages interactive and dynamic. Another big selling point of JavaScript as far as a language, and it's like, okay, why are we learning this? Why is this language important? JavaScript is a language that so many things are built on. And so JavaScript is foundational to other languages. Or better yet, libraries. And so as an example, what are some other things that are built on top of JavaScript? Well, one of the popular frameworks is called Node, Angular, React, Ajax, jQuery. Okay, and these are just some very popular frameworks that are all built on top of JavaScript. And so by learning what we're going to learn in this book and throughout the rest of this course, it'll be the foundation for all these other libraries that many of them we will use here at Rankin and are very commonly used in the industry. So what we are learning is kind of the foundation of JavaScript, or what I refer to as vanilla JavaScript. And so, well, that's how just base JavaScript that we will be learning, and then from there you build on top of it with all these other languages. So it's important to understand what we're studying. We are studying vanilla basic JavaScript. The reason we're studying it is because it's going to help us build interactive and dynamic web pages. And as our learning continues and evolves, we will learn other libraries that were built with JavaScript that are very popular and very commonly used across the web and across development, that this foundation will help us with. So does that make sense, guys, as far as, what we'll be using JavaScript for and why we're learning it, so on and so forth?
Yeah, it makes sense.
I always kind of default to this developer survey because it's a huge survey that's done every year. And when you kind of look at the most popular technologies, JavaScript is listed as number 1. HTML and CSS is listed as number 2. Python is definitely one that's gaining a lot of popularity. So it's number 3 currently. SQL in the curriculum, Java in the curriculum, and then there's Node, and then there's TypeScript. TypeScript's another one that's built on JavaScript that I didn't list. C#. But I just wanted to kind of show that this is the most popular technology as far as this developer survey is concerned. I can click on professional developers and see just the same kind of, actually a higher percentage of professional developers. And I've always gone as far as to say that if there was a single most important language that I think that you could learn, this would be the language, because there's hundreds of potential choices and languages that are out there. But JavaScript would be the one, in my opinion, that would be the most important to learn. Now, as we're looking forward, last semester for the first time, we also introduced our first framework of React, and we introduced React into this class. And so this class will be will have that same introduction to React. Now, React is a framework where JavaScript can do both front-end development and back-end development. And so historically, JavaScript was always just used in the front end, and that's what we are teaching when we're teaching about vanilla JavaScript. We're teaching about front-end JavaScript. But with React, we can actually make what are called full-stack web applications that include JavaScript running on the server, aka the back-end code. And so when you look at popular web frameworks, React is something that we will dive deeper in third semester. And kind of our objective in this class, towards the end of it, we'll get an exposure to React. And we used to teach jQuery. I used to teach jQuery, but that got replaced recently by React. And so that was something that for me, I kind of found a little confusing, that I've always just studied and known JavaScript to run in the client or on the web browser. And so the JavaScript that we're going to write, that's how it's going to run. But this is some technology, if you will, that kind of changed all that. That was introduced and became really popular within the last 10 years. So just wanted to show this as far as web frameworks go. C# is this ASP.NET and ASP.NET Core, and so when you take C# and run it on the back end of a website, that's where you get into this technology. When you take a language like Java and you make Java run on the back end of a website, you're going to run Spring. And so when it comes to these web frameworks, and And obviously that's the direction the web, software is heading. Software is all heading to be web interfaced. React is the most popular web framework. So just another way of showing you that JavaScript is really popular. But all that just to say, these objectives that we kind of started with here, these are those foundations of working with JavaScript. And so right off the bat, the slideshow gets into how do you link to an external JavaScript file. And, if I kind of go back to what we've been doing with HTML and CSS, we're in JavaScript Chapter 2 now. We remember how to link to an external CSS file with this link tag. JavaScript, there's a script tag, and actually if you kind of see here, there's a script with a source attribute. And so, we might just call this script.js. And so we would have an external JavaScript file called, whatever it may be, script.js, and this script tag would be how we link to an external JavaScript file. And just like with CSS, you can write CSS in different places. You can write CSS in an external file. You can write CSS embedded. Well, we can write embedded JavaScript. We could just write a script tag like this and write our script embedded in the head of our document. We could write JavaScript in the body. And this is kind of like the embedded equivalent of CSS. And just like with CSS, ultimately there's kind of a best answer. And the best answer with CSS was to write external CSS. And that's very much the case with JavaScript. The best way to write your JavaScript in most cases is to write external JavaScript. And the reason that is because it creates the most reusable code. If I just write a script tag, in the head of this document or in the body of this page, well, then that's where my JavaScript exists, and that's the only place that it can run. However, if I make a new file called script.js, then I can essentially link to that external file across hundreds of HTML documents. And so I could reuse that JavaScript in many HTML pages. Versus if you kind of write the embedded script, then you're really only going to be able to use it on that page. And so just like when I was demonstrating a lot of my CSS, I would write embedded CSS just because it's kind of faster that way. I can just write a style tag in that case. And I'll probably do the same thing here. I'll probably write some of my JavaScript in its own script tag. However, that's certainly not considered best practice. Best practice is to contain your JavaScript in an external file. Okay, so you can put JavaScript in those various places. And there's one additional attribute called defer that you should include. And so this is essentially the best answer to how should you link to your external JavaScript. You should link to it with a script tag, with a source attribute kind of identifying the location, the relative location of the script. And then you want to include this defer attribute. And in on Inside Rankin, let me go ahead and pull up our class here. There is a handout that, just like we had a handout for HTML and CSS, there is a handout for JavaScript. And so if you kind of scroll down here, remember we had a handout for Flexbox and Forms. Handout number 5 is for a lot of JavaScript in this 5th handout. And this first block kind of talks about the advantages of putting it in different places, putting your script tags at different places. Now, for a long time, I always learned that it was considered best practice to include your script at the end of the body. And so what that meant would be like, here you would have your H1, in your divs, in your mains, and your footer. And then I was taught many years ago to have a script source kind of down here. Okay, and the reason I was taught this is because, the page loads top to bottom. And so the user, they want to see their content. And if you would have a script tag without the defer attribute, if you would have this script tag without the defer attribute in the head, let's pull this up. You would kind of see here the script in the head, it would pause the rendering, meaning the drawing of your page, while the script is being downloaded, and if it's starting to run and execute. So in other words, like your images wouldn't be drawn on the page. And essentially what that did, it created slow loading pages. Now the file itself, because it's up in the head, the script itself would be downloaded, immediately. So, but to the end user, while if it was a large script file, while that script is being downloaded, they're not seeing much on the page. Like it's an empty page, or they're not seeing much. And so it created this perception of slow load times, and it created slow load times. It wasn't really a perception. It was what would happen, right? So then I kind of learned, well, hey, go ahead and put your script at the end of the body. And then that way the browser continues to draw the screen, continues to render your HTML until the script tag is encountered. Well, so if you kind of put it down here, then all of this is going to be drawn on the page, and then your script is going to be downloaded kind of at the end. So all of the main content is displayed. Maybe the user can start reading your content, and the script is then kind of downloading in the background, and they're not waiting on it. Sorry for clicking around. Let's back to this. However, again, the download didn't start until the script tag was encountered. And by the downloading of the JavaScript file itself. And so what could happen is the user starts to interact with the page kind of quickly. And if the user is interacting with the page before the JavaScript was done downloading, that could kind of create a weird scenario where the page isn't responding how it should. And this kind of works with inline scripts. Well, the inline scripts are the equivalent of what I was referring to as the embedded CSS, when you just have script that's in line with the HTML. So when you have a script tag like this is your like an embedded or inline JavaScript. You can also write JavaScript literally like on click equals, and you can write JavaScript right here, like you know, do something. And so but you know, kind of getting here, which was going to be my recommendation for this class, when you're linking to an external JavaScript, we want to do it in the head with the defer attribute. It says execution is paused until the DOM has been parsed. What that means is basically all of the HTML has been loaded by the web browser. So the web browser has loaded the HTML. It understands the hierarchy of the HTML. The download begins immediately, but it does not support for inline scripts. And so this is kind of the best solution as far as you're not going to have this scenario where the user is interacting with the page and it's not behaving appropriately. You're not going to have this scenario where the page is like appearing to download slow, or it's appearing to load slow. It's going to start loading the page right away. It's going to download the JavaScript immediately, but it doesn't really support inline scripts, meaning it's not going to interact well with these kind of embedded scripts. Or if you start writing JavaScript in line with HTML elements, which you occasionally see, it doesn't play so nicely. But basically, the short answer is we're going to put most of our JavaScript in an external file, and we're going to link to it in the head with the defer attribute. And that's kind of the best case scenario for us. That's the best answer. So that's how you're going to want to load your script. And so here's a little bit of script, and we can kind of look at this. Where you can write a script tag that's literally in the body of the HTML. This is fine. What does this script tag actually do? We ask the user, we prompt the user to enter some number of miles. And then we store that data in what's called an integer or whole number. So there's a lot going on here, and don't this is not the important part, you know, is like understanding every line right now, but I just want to go through it. So here's a little, you know, we ask the user for miles, we store that information. We ask the user for a number of gallons, we store that information. We do a little calculation, which is miles divided by gallons to get the MPG, and then we pop up the miles per gallon in a little alert box. Now, this is like chapter 2 stuff, and so in most of the JavaScript, we're not going to be using alerts. And I got all these script tags, so let me kind of clean all this up. But what they're doing here is an alert. Hello world. So we're linking to a JavaScript file, and this is what an alert does. In chapter 2, we kind of start with alerts, but in the real world, we don't really use alerts. It's just a way to kind of start learning this stuff. Very quickly, what we'll do is we'll start putting stuff into paragraphs. So here's a paragraph, which the ID of hello. So in CSS, we learned how to target this paragraph using the number symbol, right? So if we wanted to change the color of this paragraph, we could target it by its ID. Turns out JavaScript has the same kind of functionality in that instead of, we could do document.getElementById, we called it hello.innerHTML and I do this all the time where I launch the page and it basically launches a directory. So I needed to launch the HTML page. So when you launch the HTML page, well, there you go. I've written a little bit of JavaScript, and now I've gotten my feedback instead of in a little alert. Now I've got my feedback literally put into this paragraph with an ID of hello, and then my output is hello world. So to kind of go back to my example here, now this starts to download and run immediately. So it does download the HTML and is able to work with the HTML pretty much right away. So right when that page loads, it's able to get the element by its ID. The ID is hello. So this word that says, document, this refers to what's called the document object. Really what that is your HTML. When the keyword document, and it's all lowercase here, the keyword document refers to the HTML document. Then we've got this method called GetElementById. This is how we're going to target our HTML. Basically, hey, I'm going to look for an HTML element by the ID attribute. The ID attribute, we called it hello, and we're going to change its inner HTML to say hello world. Inner HTML doesn't change the paragraph tag itself, it just changes what goes on the inside right here of that element. Right, so it doesn't change the paragraph tag itself. It changes basically what goes in the paragraph. And so, yeah, what's up, John?
So you did get element by ID. Can you do what about a class?
Yeah, so there's all sorts of ways that we can select elements, and so you can kind of get elements by class name right here. Now it is interesting because notice that getElementById is singular, getElementById versus getElements by class, because keep in mind you can have multiple elements with the same class. Right? So that creates a little bit more of a complex scenario because this one is supposed to target one element. This one would actually target multiple elements. So this method works a little bit differently for that reason, but that should answer your question, yeah?
Yes.
Yeah. And so you might say, but hey, Mr. G, why would I ever do this? Like, can't I just take this content and put it inside of this paragraph, and then now I don't need the JavaScript? And the answer is, well, yeah, except for we're not going to be doing this when the page loads. Essentially, right now, this JavaScript is running basically, when the page is loading, right? So eventually, and pretty soon here, we're going to start doing things when the user interacts with the page, right? So maybe the user clicks a button, or maybe they hover an image, or maybe they click on an arrow that represents, scroll to the next image in your image slider. Right? Or maybe they click a calculate button, or maybe, the point is we're going to learn how to do this on an event, versus just writing it as the page is loading. One
more thing is, so do you end with like a semicolon?
Yes. And so at the end of a statement of like an English statement, right, we kind of terminate our sentence with a period. JavaScript's end of a statement or end of a sentence, if you can look at it that way, ends with a semicolon. Now, one of the reasons I said that JavaScript is a good first language to learn is because sometimes it breaks pretty hard. Sometimes, forgetting something like a semicolon actually might not break your whole. It might not break. So JavaScript can be a semi-forgiving first language to learn in comparison to other languages. Now, they had a keyword called let. And so there's a couple of things going on here. In any programming language, we're going to work with data. So applications, apps work with data. And data is the most important piece on any IT network of any IT network, software, infrastructure. The data is always the most important thing that you're working with. So how do we work with data in software? We work with these things called variables. Variables. You think back to your math class, and you'd always have a variable called x, and x would be equal to some value. And it kind of works the same way here. Our variable isn't called x though. Our variable is called name. The way that we create this variable is we use this keyword let. Turns out there's a couple of keywords here. The old school way is creating a variable with the var keyword. That's not really recommended anymore. So instead we use the keyword let. And the reason it's called a variable is because the data can always be updated. So here on line 3, we create this variable called name, and we assign it to Evan Gudmestad. And then on line 4, we kind of update this variable to hold the name Evan instead of Evan Gudmestad. Now, my linter here is telling me to use single quotes, and so it's kind of barking at me like such, which is just a recommendation. And then it does want me to have this use strict keyword, which is we'll learn about what this use strict does for us. And what it's saying here is it's saying, hey, you've created this variable called name, but you've never actually used this variable. So instead of putting the word, the words hello world here, I'll just put the variable name in here. And it's actually, name is not really a good identifier. So this is, instead of calling this X, we call it name. That's kind of our current, maybe we'll call it username instead. Username and username. Okay, kind of get rid of some of this problem. All that's just to say, what is this going to output? Well, you could see it's outputting the word Evan, right? What am I getting at here? Kind of what's the point? Well, variables store and work with data, and as the name suggests, the data can vary, right? the values that they store can change over time. Okay, so for a long time when we worked with variables, we used the var keyword. That more or less has been updated, like 2015 time frame. var kind of created some security holes, so they updated it with this new keyword that's called let. And so if your variable varies, like mine did here, right? My name went from Evan Gudmestead just to Evan. And so the data is changing inside of username, inside this username variable. That's when you use the keyword let, is when the data is going to vary. However, if you know that the data is just going to be stored and it's not going to change, there's one more way of creating a variable, and that's with the keyword const. And maybe something like, sales tax is always going to be 0.075%. And again, it's assigned a value but never used. I'm not worried about that. So the example that I'm showing you here is that here's a variable that the data changes. Therefore, because it changes, we're going to use the keyword let. Sales tax is also a variable. It holds a number, so it's not in quotes. Whereas this just held a name, which, it can hold all sorts of things. It could hold special characters, it could hold spaces, it can hold, again, special characters. It can hold all sorts of characters at the keyboard, right? So you would refer to that as a string, whereas this is a number. And so these are the ways to create variables, and this is kind of a foundation of JavaScript, is working with data, manipulating data, and then updating what the user sees based on how they're interacting with that page. So here they're creating a variable called miles. Here they're creating a variable called gallons. And let me just use this prompt and update this. So maybe we ask the username, please enter your name. And then we'll do document Getelementbyid. What do we call it? We called it hello dot enter HTML equals username. Right, so now we're getting a little bit of interactivity in that the user can type their name and we just put their name back to them on the screen.
I'm assuming the built-in style sheet is what made the text box look that way?
Yep. Yeah. The browser decides what that prompt looks like. We don't really have any control over that. And so this will take the username plus a value, say Billy is 9 years old kind of thing. Right? Now this runs together. Why does this run together? It's because we need a space after the username so that the word is doesn't run like right into the username. So we could fix that by coming in here and adding a space right there, so it says Billy with a space, is years, that many, and then a space after years, old. Okay, and this is an older way of outputting this information. What we're doing here, this is called concatenation, which is just a fancy word for, taking what goes inside of quotes, which is strings, and we're adding these variables into our strings. So when we add variables or we add data into the strings, we concatenate strings, or basically add them together. So basically this is going to be one big string that says Billy is 9 years old. Right? Yeah, I launched the page twice, and that's what, if you don't answer the question, it's going to say null, null. Like if I just hit OK, OK, there's no data that was ever put into our variables. So those variables are basically, undefined, and we'll kind of talk about that, or empty. Actually, in this case, they're empty. So that's kind of the output that you get. Now, very, very recently, it's kind of interesting, Firefox has been making some headlines. I don't know if you guys saw that over the weekend, where Firefox has always been known for being the secure browser. Not the most secure browser that I'm, there's other browsers like DuckDuckGo that really have a good reputation for security. But Firefox has been known for security, and Firefox did an update, and they no longer supported what were called third-party cookies. And what a cookie is information that a website collects about you and kind of stores about you. And then some websites can sell that information to other websites. And so, you might go to a website and they collect information about you and sell it to another website. That's called a third-party cookie. And so Firefox did this big update, and that's all done with JavaScript. Cookies are all done with JavaScript. Third-party cookies, therefore, are all done with JavaScript, and it is big business on the internet. Selling user information that comes in the form of cookies is big business, and so Firefox really is kind of shaking the business model of a lot of companies that work with and sell information. Apple kind of did the same thing, where they turned off a lot of tracking location about their end users. That Facebook used to rely on that to sell ads based on where people were and their movement patterns. And so these kinds of increased security decreases a lot of profits that these companies can make. Point is, a lot of people, for security purposes, might not trust all the different things that JavaScript can do, because JavaScript is really powerful and it can track you and this kind of stuff. So users might use software like Firefox and other things that are out there, like uBlock Origin and all these different tools that can disable JavaScript just because they don't trust it. I'm sure you guys know someone who generally just doesn't trust the web and the internet, and so they might disable JavaScript. There are many tools out there that can just straight disable JavaScript, this no script tag is just a way of letting the user know, hey, you're kind of missing this feature on this site because you've disabled JavaScript. So if you want to use our website and get everything out of it, you might consider turning off those security features. All right, so that's all that tag is. That's just an HTML tag that. And here you could see kind of even built into Chrome how to disable and how to enable JavaScript. Okay. Okay. So slide 11 talks about the basic syntax rules for JavaScript. Syntax rules are the rules of the language, in that, English language has a syntax such as where do capital letters go, and where do the periods go, and where do the commas go, and where do the semicolons go, So every rule kind of basically has a rule, every language has a rule set to follow, a set of rules to follow. And so that's what these are. These are kind of, what are the basic rules of the language that we will need to follow. And so JavaScript is case sensitive. And so you'll notice if I change any one of these letters, like that's a capital E, if I lowercase that, first off, luckily my linter lets me know that that's a problem. But also, functionally, it no longer works. And so sometimes it does work. JavaScript can be forgiving sometimes, but it can also be pretty unforgiving at times. And so sometimes you're fortunate, and sometimes you're not, as far as that goes. So it is case sensitive. Luckily, Visual Studio Code's pretty great in helping us fix that. But even the same thing here, hello on my ID doesn't match the hello right here. And let's refresh that. And yeah, it's not working, right? So JavaScript is case sensitive. Just demonstrated that. You should end with a semicolon. It's considered best practice. You've seen that doesn't always cause problems, but it can in certain cases. So definitely best practice. JavaScript ignores extra white space within statements. Again, a statement is what ends in a semicolon. And so, like, for example, right here, if we put extra white space in our statement, that will ignore it, so there's really no point in doing that. But that would be ignored by the engine, what's called the JavaScript engine, that ultimately runs your JavaScript. And then when JavaScript is in strict mode, it disallows certain JavaScript features and coding practices that are considered unsafe. And so kind of back here, you can put this in single or double quotes. You put this little use strict up at the top. And it says strings must use single quote. Again, that's just a recommendation by our linter here. And so this is just considered a best practice. This use strict was introduced. So JavaScript as a language is evolving. The versions of JavaScript are called ECMAScript, and so ECMAScript are again, these are the versions of JavaScript, and you kind of hit up the Wikipedia and see the different versions from the 4th to the 5th, and then they started going every year. So they started being released every year around ECMAScript 2015. And then people just started referring to them by the year. And so JavaScript as a language is always evolving, and this use strict came in around the 6th edition. Actually, I'm sorry, it came in the 5th edition. And has been around, since then, December 2009, so it's been around, 13 years, whatever, 14 years. So it's just considered best practice. And again, it kind of patches some things that were considered bad practice. And, we'll get into, like, for example, creating variables without the keyword let is an example of something that would not be allowed. Like if I just wanted to have a new variable, here's username and user age, and I would say like user address equals 23 Rankin Lane. It's going to say, hey, user address is not defined. Well, how do you define it? You give it the keyword let. And then if you were to use it, that problem would go away. So again, in this first chapter, I don't think you have to be so concerned about what exactly every line is doing. And so here, essentially we're making a block of code called a function that you can maybe, you click on a button and then you run this block of code called join list. Here's the strict mode. We read some values, probably out of a text box. Instead of doing an alert now, we're reading values out of a text box. I'll have to explain a little bit of what's going on with these dollar signs. You can't assume anything about that. We're doing a little validation here. Like if what the user typed in is empty, then we give them a little error message. Or if this is empty, we give them a different error message. If the email addresses are not equal, you give them this error message. And so essentially this is doing some form validation for us. If you get a long line of JavaScript and it needs to be split, a general recommendation on when to split a statement is after an arithmetic or relational operator, like the plus symbol, minus, multiply. You can split it after an opening brace or a bracket or a parenthesis or a closing brace. Do not split a statement after an identifier or the return keyword or a closing bracket. So just a couple of recommendations. You won't run across this super often, but okay. So rules for creating identifiers. So what are our identifiers? Well, right now I've got 3 identifiers, and these are what I just referred to as variables. Okay, so here are some general rules around creating these identifiers. Now there are other identifiers besides variables. For example, back here we had this function called join list. We get to also, name our functions. So an identifier is just something that we get to name, right? So for example, if you have a child, you get to identify your child by their name. Well, we get to identify things in programming as well. We get to identify our variable names and we get to identify our function names. And those are 2 very common examples of identifiers. And so in JavaScript, so there are some rules around creating identifiers. So you can contain letters, numbers, the underscore, and a $sign. So right off the top of that, these are what are allowed as identifiers. So you're going to notice like there's no special characters, like exclamation point, right? That's not a valid character in an identifier. So we are allowed to have letters, numbers, an underscore, and a $sign. So we could do underscore username. That's valid. We could do $sign. That would be considered valid. But pretty much any other special character is not valid in our JavaScript identifiers. It's also true that they cannot start with a number. They can contain a number, but they just can't start with that number. So we can't do like to username, like for the second username or anything. We could call it username 2, but you just can't start it. JavaScript is case sensitive. Identifiers are also case sensitive. They can be any length, but they also cannot be reserved keywords. So, like for example, we'll learn that the for keyword it has a certain meaning in JavaScript, and so because the keyword for has a purpose, this is not allowed. We cannot create an identifier that is the same name as a keyword. And there are, so these are reserved words, all the different keywords, but there's also like GetElementbyId. Like I probably wouldn't want to have another, GetElementbyId. Like that's not a good practice because that has a very specific purpose in JavaScript. That method does. Okay, so a couple of examples of valid identifiers. Again, letters, numbers, underscore, $, can't start with a number. My convention pretty often is camel casing. Camel casing, your identifiers start with lowercase letters, and then every new word capitalizes the first letter of that word. So tax rate, calculate, click, email address. This is kind of the convention that I use. There's also snake casing, which uses the underscore that the textbook uses. So you can use either or. There's no right answer, but it is a good idea to pick a convention, because this is just a convention. Pick a convention and stick with it. You also want to use meaningful names for identifiers. So, one of the first variable names that I referred to was the variable x in your math class. But x really is not a good and meaningful name in that, I don't know what x is. Like I know what Illinois tax rate is, IL tax rate. That's meaningful, but x, I'm not sure what x means in the context of your software. And again, just be consistent with camel casing or snake casing. Either way is fine. If you use snake casing, use lowercase for all letters. Okay, and again, this is a list of keywords that as we go through this class, we will learn many, if not all of these keywords. And again, so why is this relevant? Well, because these are reserved and we cannot use them in our identifiers. Comments are important for a lot of reasons within code. In JavaScript and in any coding language, comments are used for a lot of things. Here you could see I used comments just to make a couple of notes, and that's not really one of their main uses. So comments can and are often used for documentation purposes. You often want to document the purpose of a chunk of code for other developers who are going to look at your code and try and understand it. Okay, so it's really good to document your code for the purpose of explaining it. For explaining it to other developers, or just as important, explaining it to your future self. And what I mean by that is the code that you write today, you know, in 6 months, you know, you're going to work on other, you know, chunks of code, and you're going to forget all about why you wrote the code the way you wrote it today. So in 6 months, when you're reviewing your own code from 6 months ago, you might want to explain your logic or your theory, why you wrote the code the way you wrote it, in comments. And so it's for documentation purposes for developers, be it your coworkers or be it your future self. So documenting your code is one ginormous reason why we write comments. You'll notice there's also multi-line comments in JavaScript. So this is a multi-line comment. It's good for adding a lot of description. And so multi-line comments are done with a /* and then terminated with */. So a single line comment is done with 2 //. So these are the different ways of commenting. Another very common reason we add comments are to troubleshoot your code. And so if you're trying to fix a bug, you know, maybe you're not sure why this code isn't working, and so you could start by, you know, commenting it out one line at a time. Maybe I just want to try commenting out line 18 and now seeing if my code works, right? Because if my code suddenly starts working, then maybe I know that 18 is causing the problem, right? So documentation purposes is probably the main reason that you comment things out, but you also use comments in troubleshooting fairly commonly. Okay, so again, the guidelines, you know, hard to understand parts of your code. If it's easy to understand, not everything needs a comment, right? So if it's easy to understand, you know, you don't need to add comments, but more difficult parts of your code. I gave an example where I commented out line 18 because I thought maybe line 18 was causing a problem, like causing it to break. But you could also comment it out if you know line 18 is good and you don't need to test it. So it could go either way. You know, it's like, hey, I know this function. I know this function isn't causing my problem, so let me comment it out and let me focus on the other areas of my code that may be broken. Okay, so again, there's just a bunch of new terms in JavaScript that we've kind of gone through today. That we've seen in this lecture. So slide 22 is important because JavaScript has what's called an engine, JavaScript engines. And the engine is the software built into the web browser that runs the JavaScript. And so, you know, it's easy for me to remember, you know, I'm not a big car buff, but if you are a big car buff, right, you think, oh, I got a big V8 engine, right? So the JavaScript engine inside of Google Chrome is called V8, right? And again, this V8 is just the name of the software built into Chrome that runs JavaScript. One of the reasons why Google Chrome is known for speed and being fast is because of this software. This V8 software is really good at running JavaScript fast. And so it's not the only JavaScript engine. You could see Mozilla has a different brand, if you will, of a JavaScript engine called SpiderMonkey. So that's kind of a fun name. JavaScript Core is what's built into Safari. And there's another one here for Internet Explorer. Chakra? Is that how you say that? You can kind of read here, but Edge was later built on Chromium and now uses V8. So if you're using older Internet Explorer versus using the newer Edge, Edge just uses V8 just like Chrome does.
Were they say Chromium based? Does that mean they just like reskinned Chrome?
Yeah, they took the code kind of like template, right? And they started from a fork, is if you're familiar with like a copy of the code. They started from a copy of the code and made changes to it.
Oh, that's interesting. You just assume they all built from scratch.
Yeah, they did for a long time, but Chrome was so much faster than Internet Explorer that they eventually, threw in the towel. So when it comes to, why did I even bring that up? So why did we get into this rabbit hole? Well, in JavaScript, let me kind of bring this back. We have an identifier called username, and we put it in quotes, and it's going to want me to put it in single quotes. Well, the other languages, we just use the keyword let. Other languages, like C# and many others, you have other data types here. You might have a string, or you might have an int. In JavaScript, the engine automatically figures out the data type for you based on what you put into it. So, here on line 3, I'm creating a variable called username. So that's what let does. It says create a variable. I'm calling it username. We're giving it a value. So to the right of the equal sign is what we put into our variable. And because it's it's allowing the user to kind of type. I can type whatever I want. I'm going to put it in quotes. And the JavaScript engine, and because I'm in Chrome, it's V8. The JavaScript engine says, oh, I know that's in quotes, and because that's in quotes, it's a string. So it basically handles that for me in JavaScript. Whereas other languages, you have to be more specific with your data types. So JavaScript is pretty smart. Like these JavaScript engines say, okay, based on what you put into the variable, okay, well, I don't have quotes here. In fact, I just have a number. So there's actually a data type called number. And numbers can hold whole numbers. They can hold like 30 cents change, right? A leading decimal point could be confused with a dot. So you could do something like 0.30, and that gets rid of that error. So both this number 5, the JavaScript engine says, okay, we're just going to put that in a number. That's the data type. And there is no number data type in C#, but there is in JavaScript, and it's just handled for you. There is a string in C#, but again, it's just declared with the keyword let. Let is old enough equals true. You can also hold true and false values, what are also called Boolean, right? So you store Boolean variables inside of let. And again, the JavaScript engine just kind of figures it out for you. There is a null data type. These are ones we're getting into less and less. But null, so like let some data is null. So that's actually considered valid. That you can store. So null is the absence of information. So you could view a number like 0 and say, well, 0 is the absence of a number, but well, 0 is a valid number. So you can be, 0 days old kind of thing. And so if you want the absence of number or the absence of data is where you store null. Undefined would be, let's do this, document.getElementById. We called it hello. Enter HTML equals, and I'm going to put a variable in here that doesn't exist. I'll just call this user gender. Here, if I notice what I did here, I opened up my console. So I hit F12 and I go to console. We kind of get this user gender is not defined, which essentially means what you would assume it would mean at this point. We've tried to use a variable that we never declared. So undefined, and then big int is supported in. So we talk about the different versions of JavaScript. Oh, sorry, I'll pause. What's going on? We talk about these different versions of JavaScript called ECMAScript, and they started, referring to them by the years. And so basically in the year 2020, they started supporting what's referred to as the big integer. Integers are whole numbers. Big integers are really big whole numbers. And so, that's a valid data type in, more modern JavaScript. And so these are the data types built into JavaScript. JavaScript symbol data type. This is a lesser used one. That's not what I was looking for. Symbol type. That's it. So this is something that is pretty common where, if you have a unique ID, so like at ranking you might have a unique student ID, this symbol will, this built-in method will allow you to generate something that's unique and let's see. can I convert it to a string? To string? Okay. I'll do a little digging on that symbol. Something that's a little bit newer. Okay, so again, examples of number values, whole numbers, negative values, decimals, these are all valid. Negative decimal, you know, they got scientific notation. In JavaScript, it's the same thing as E notation. So this would be like to the negative 9th power. So a really small number. So these are all string values, whether it's in double quotes or single quotes. The big thing here is that the quotes just have to match. So an opening double has to be closed by a double. An opening single must be closed by a single. An empty string is also a valid value, right? Like it's kind of the equivalent thing what I said earlier, where 0. Well, 0 is a valid number. There's a difference between an empty string and null, for example. So here's, again, we can store Boolean values. Here's declaring multiple variables on the same line, multiple data types. Here we assign a variable the value of 1, and then we update it. We say, okay, this is definitely new for a lot of first-timer programmers. Say, okay, we'll create this variable, holds a value of 1, and now we say, okay, the new value of our variable is assigned the value of its current value plus 1. So it was 1, and this is basically how you update it to 2. Right? So it says the new value is the current value plus 1. Whereas a const cannot be updated. The whole idea of a const is it remains constant. You can initialize it to a value, but then you cannot update it. So where do these variables go? Well, ultimately they go in your computer's RAM. And so this process is called hoisting, kind of a fun term. The point is that, you know, for example, you can have multiple variables across multiple files, and because they're running out of your computer's RAM, these variables can, if they're referred to as global variables, they can work across scripts. So multiple scripts kind of working with the same variables, working with the same data, because ultimately it's working out of your computer's, here they refer to memory as RAM. When a variable that's been declared with var is hoisted, JavaScript initializes it with the value of undefined. Because of this, you can access the variable before you declare it. Again, this is basically the old way of declaring variables. When a variable that's declared with the keyword let is hoisted, JavaScript doesn't initialize it. That is also true of constant. Because of this, you can't access the variable or constant before you declare it. The short version of this is you want to use let and const because this is referred to as scoping, and those global variables that I talked about, those actually can cause a fair amount of conflicts when you start having variables across multiple scripts with the same name. And so you want to minimize that as best you can, and using the let keyword or the const keyword is how you'll do that. And And so they go through here and they say, hey, if a variable was declared with var, the output you'll get is undefined, versus let, you'll just kind of get nothing display, which is exactly what happened in the example that I did earlier. Again, like these slides are more or less terms that we've all covered at this point. A variable versus a constant, how to declare it. Well, you declare it with the keyword let or const. Initializing versus declaring. The initialization happens when you give the equal sign. So this is referred to as the assignment operator, and when you initialize it, it's like basically the first time you put data into it is when you initialize a variable. The assignment statement is, again, so the initialization is the first time, but then the assignment is every time you put data in. The assignment operator is the equal sign. A literal value would be something like this. On line 3, this is a literal string because every time you run line number 3, it puts the same value into the variable, right? Versus if I were to do something like this, right? This prompt is no longer a literal value because now every time this code runs, the user can put in their name, right? So a literal value is a number or a string or a Boolean or something that is hard-coded and every time it's going to run the same way. So that's a literal value versus something like where you're getting input from the user and it might run differently every time. And I'm not sure if I took this out. This temporal dead. Let me see if this is something I want to talk about right now or later. I think the answer is later. This is not a conversation for day one JavaScript. Okay, so as this is just, a lot of the foundation or fundamentals of JavaScript, pretty quick we'll learn that, we're going to be doing some basic math operations, addition, subtraction, multiplication, division. These are all, standard when you're problem solving. We're going to be doing some basic math. Modulus is the equivalent of the remainder. So, when you have, 10 divided by 3 would be 3 with some remainder of 1, right? So 3 remainder of 1, or you could say, 3 point, what is it, 333, something like that. But the remainder, right, is 1. So 10 divided by 3 has a remainder of 1. So modulus would give you the remainder of 1. And then if you want to take a variable and increment it by 1, you could always just do plus plus or minus minus. And so these are common operators that you can use in JavaScript to do a little bit of math. And we will definitely use them. And so just like in your math class, there's order of operations. There's order of operations that work pretty much the same way. Please excuse my dear Aunt Sally. Parentheses, And I never learned it that way. So parentheses, I just had to memorize it back when I was learning it. E would be exponents, I'm guessing. Please excuse. Multiplication, so on and so forth. So the point is, take that same math class and order of operations, and they're applied here. The plus, plus, and minus, minus take the highest precedence. So you're going to do that first and then do the rest. A bunch of math examples, but again, this is right out of standard math class. 13 modulus 4, right? 4 goes into 13 3 times, which would be 12, and then gives you the remainder of 1. So that's one that confuses newer programmers. And I think these examples just do some basic calculations and store them in variables. So here, this is 200.05. Tax amount equals 200 times 0.05. Right, total is these two things added together. The perimeter is 2 times the width plus 2 times the length, storing it in a variable. It is pretty common to say, okay, let number equals 10. Number equals number plus 5. As you might expect, I keep forgetting the name of my ID. So we start off our variable as a value of 10, and then we say the new value equals 10 plus 5 or 15, and then we're going to output 15. All right, so that kind of works how you would expect it. There's a shorthand for doing line number 5, because it is a very common thing in programming to take some sort of initialized variable, meaning the variable has data in it already, and then assign a new value based on its current value. So we could do the same thing, number plus equals 3. So this is going to start off at 10, it's going to add 5 to it, so we're going to get 15, and this does the same thing. It's going to add 3 to the 15 to get 18. Right? So this is shorthand for this, right? Line 7 is a condensed line 5. Right? You could see that it works the same way. We're just adding 3. And you could do addition that way, subtraction, multiplication. These are what are referred to as compound assignment operators. Okay, we can do the same thing with plus plus, number plus plus. It just takes it up by 1. Sorry, so here's 10, we take it to 15, we take it to 18, and then this takes it from 18 just to 19, goes up by 1. So very common to increase a variable by 1 or decrease it by 1, and right, these both functionally work almost exactly the same way. You're going to see it's going to output 20, so there is like a really small difference between the two that I don't need to harp on right now, but just, we'll get there. You'll find out pretty quickly that when you do some math, you're going to get basically a rounding error. So we'll learn some methods to basically round up. And so $7.49, you might want to round that up. 7,495, you might need to round that up to 750. And so there's a rounding function in JavaScript that'll allow you to take off all this trailing decimal that we really don't need. All right, and I think it's a good point for another break. Let's take another 10 minutes. Okay, we left off on this slide that talks a little bit more about a term I've used a couple times, is this concatenation. And if we remember, concatenation is where we took our variables and we added them into strings. And so, you could do something like, say, the number is, and then we took our variable. And this is this right here, this plus. The plus symbol can do addition. And when you got a number on the left side and a number on the right side, the plus symbol adds. But when you've got a string on one side and a number on the other, it concatenates. In other words, it adds it to the string. And this is this is the old way of doing concatenation. Turns out there's a newer, much nicer way of doing concatenation. And down here is that way. And so I want to talk about these template literals and how they work, because it turns out if you've got a lot of strings and a lot of variables, that this is just kind of cumbersome. And then if you got multiple lines, you got to have a plus down here. And so that should work. And so that's, again, that's the output of all that concatenation. And turns out there's a little bit easier way of doing this. And that's with these template literals. Now, the symbol on these looks like a single quote, but it's not. So if I type a single quote here, that's what the single quote looks like. This is actually, on my keyboard, this symbol is right above the tab key. And so that symbol is how you start a template string. And so if you want to include a variable into your string, you would put the string, and then you put a $sign followed by curlies, and then you can put your variable right in here. And then you don't have to break it up. And then if you had another variable, you would just put $sign, curlies, like such. And so this is a much nicer way to concatenate strings. And yeah, it's nice. Right? And so multiple lines kind of demonstrated that. If you do want a new line in your template string, you can put a backslash. And so these are your special characters. Like in front of the word plus symbols, I'll just do a \n. And that's going to get a line break to happen. Now, doesn't affect HTML, but does work in the text, alerts, and prompts. Okay, I was going to say it would got to think on how that would interact with the HTML, because Paragraph is a block level element. It causes a line break at the beginning and the end, but not in between. Single quotes. So these special characters, single quotes, backslash, single quote would be how you get a single quote to actually show up in the string literal. Backslash double quote, same thing. So these are just special characters. You have to code a special way to get single quotes to show up in the string and double quotes to show up in the string. To get a backslash to show up once, because the backslash is the beginning of the escape sequence, you need to do backslash backslash. You can also write Unicode characters. So this is a Unicode like if you open up the char map, you can get these Unicode values for all the characters on your keyboard. So U00A9, U00D7 would be that X, right? And so you can open up the char map, go to any character, backslash U058E. Let's put that in. Select. I want to get that U058E. Backslash U058E. See if I did that right. And there you go. So that's how you can get any character basically supported by your computer into your strings with Unicode. Okay, and this chapter starts with little pop-up windows that are not super common, so I'm not going to focus on, any more than just this one chapter of working with alerts and prompts, because again, they're not super common. But an alert is just a message that you give to a user. A prompt is kind of a request for information. They both belong to what's referred to as the window object. So you might see it written as window.alert, or you might just see it as alert. This window object is referred to as the global object, so you don't have to code it. It's assumed, if you don't code it, that it belongs to window as this global object. It works that way. So here's an example of prompting the user for a number, and the default number is 100, so that's why it's in that text box, and then stores that in a variable called user entry. And I did that earlier, prompting the user for their name. So the syntax, very commonly found in JavaScript, is the name of your object followed by the name of your property. A property is just a piece of information, or the name of your method. So you might do window.prompt. Prompt is a method, it's got parentheses. And so a method causes some behavior to happen. In this case, the behavior is a pop-down window from the browser. So object name dot method name, but there's also properties, object.property names. Properties are just pieces of information. And so the window object has a location property that refers to as the URL of the current page. So if I kind of throw this up here, alert window.location, you can hover over and you can see this is a property. And again, this belongs to window, not windows, window. So window object alert method versus window object dot location property. The methods have parentheses, the properties do not. So let's see what that actually does. It should put the URL of our page in the alert. Okay. These two methods belong to the window object called parseInt and parseFloat. Let me show you why they're useful. You will more than likely use these before too long. Okay, so we take in two numbers, we add them together, we output it to the window, and bring it over here, refresh the page, give me a number, 3, 4, you get the output of 34. And you're going, wait a minute, 3 plus 4 isn't 34, 3 plus 4 is 7, so why is it outputting 34? Well, what it's doing is string concatenation. We are adding strings together instead of doing math. So remember how I said the JavaScript engines kind of handle the types for us? When you're prompting a user, you know, the user can type in whatever they want. They can type in the number 5. And if they type in the number 5 here, we get 5, 5 back. And that's concatenation because the user can type in anything they want. So if we're expecting a number like the number 5 and we want to add that to another number like 3, it's literally just concatenating those two strings together to give it 53 in one string instead of 5 and 3 in two different strings. And so how do we fix that? Well, we actually have to hint at the JavaScript engine and say, no, actually, I don't want you to do concatenation here. I think this is a number, and I think this is going to be a whole number. And because I think this is going to be a whole number, I want to do a parseInt. And so I'm going to take the prompt and parse it into an int. And I'm going to do this on both of these so that I'm basically hinting at the type and saying, okay, I don't want this to be a string. I want this to be a whole number. Now when I'm doing addition, it should add the numbers instead of concatenating them. And if I pull this over here and I say 5 and 3, you can see it does the addition, right? So sometimes, and I'll say most of the times, the engines do just fine on figuring out the right data type. Sometimes you have to give it a suggested nudge, particularly when you're doing addition. It doesn't have the issue, like if I wanted to subtract these numbers, well, that changes it, and it actually doesn't have that problem then. And so I really, with subtraction, and why is that the case? Well, it's because the plus symbol itself can do addition or it can do concatenation. You know, the minus symbol doesn't have that problem. And so now when I'm asking for two different numbers and like 5 and 3, you could see it does subtraction just fine. Same with multiplication, same with division. It's just addition where you got to give it a little extra help. The only difference between parseInt and parseFloat is that parseInt is a whole number. ParseFloat, if you're expecting the user to give you decimal numbers, then you would do a parseFloat instead of parseInt. And remember, on the back end, the data type is just number. You can kind of see how, like if you leave leading and trailing spaces, those are removed. And then if you give them like a string and try and parse it to an int, it's going to tell you not a number, right? So that's the last thing I didn't demonstrate would be here. If I give you the number 5 and 1, you're going to get not a number back, because you can't parse the text value of 5, or in this case, you're trying to do subtraction, but if you do a parse int or parse float, you're going to get back not a number. So there's several examples of using parse int and parse float. If you want to round to a certain number of decimal places, you can use the toFixed. So if your data type is a number, as in this variable here, and you want to round that, you can use this toFixed method. So this toFixed on anything that is a number can be used, and this would round to 3 decimal places. Right, 1415 would round up to 142. Okay, and with this, we can start solving problems using JavaScript. So in the textbook, you can go through these examples, and I definitely recommend it. Asking the user for miles driven and gallons used to calculate miles per gallon. And, here they're using document.write. You're going to notice I didn't use document.write in most of my examples, because what happens in document.write is it overwrites. Like, this is my HTML. And so I've got this nice little paragraph here that says this is my HTML. And if I come into my script and I say document.write, now what? And I kind of come in here. Sometimes a document.write, and I need to actually change this example, because sometimes it'll overwrite your current HTML. I prefer to just target something by its ID, and like paragraph with an ID of result. So then I can come into here, document, get element by ID, result, enter HTML. And now you see this result, and it doesn't overwrite the HTML that's already there. Let me flesh out this example. Do a little button click demo here. So click, not on. Is it on click? Okay. I paused and resumed. What I wanted to do just at the end here is just like the miles per gallon, maybe just a little bit differently than the book has it. And so here I have an HTML button with an ID of button click, and and maybe we'll make this say calc MPG. And so here we'll have a form, and we'll put this button in our form. And we'll put a bootstrap class of button success, and go to get bootstrap template, quick start CSS, and our JavaScript bundle. And let's just glance at it and see we're getting some bootstrap button in there. Let's go back to our forms and our classes form control and form label. So we'll do a label and an input. ID is text miles. Label 4, miles driven. And let's put our bootstrap classes on it. Classes form label and classes form control. Okay. And label gallons used. Text gallons, class of form control. This labels for text gallons, class of form label. Okay, now the JavaScript, I kind of paused and I realized I forgot to set a parentheses. And I mentioned this when it was paused, that there are a lot of ways to wire up event handlers. An event handler is just a method that runs when something occurs, when an event occurs. And so one way of doing it is kind of with this arrow anonymous function. And basically it says, hey, get the button click, and when the button, the on click event, literally when the user clicks, run this arrow function. It's an anonymous function. It doesn't have a name, and basically do this. And this becomes, right now I just wanted to say hi. And so literally I click the button and the button, it says hi. Okay, now this is just so I can get it wired up, meaning I know that now this code block is running when I click the button. And this is one way that we're going to be wiring up events in this class, and so I just wanted to show this way as the first way that you saw. Okay. Another thing you could do is a console.log. This does the same thing, but instead of popping up in your face, now you can see it's popping up and saying hi, and then it's going away. Why is that happening? Because it's actually submitting the form. And so you can actually see when I'm clicking calc miles per gallon, this little refresh icon is going to an X. And so the page is submitting, because button, I want to do type of button. so that now it doesn't actually submit the page. It was a submit button, which was submitting. And now you can see every time I'm clicking, you can see this little counter of a console log basically giving me a message. And so instead of giving me an annoying pop-up, I'm using the console to make sure that my event handler is wired up properly. So just a little couple one-offs there. When you have a button, you want to give it a type of button so it doesn't submit the page. And this is how we're going to wire this up. Now, what will we do is we're doing miles per gallon. So let's declare a variables for miles and gallons used. Let miles driven equals document get element by ID. What's the ID of the text box? Text miles. Text miles dot value. Whoops. Dot value. Read the value from the text box into a variable. So that's miles driven. Same thing here for gallons. Text gallons, I believe. And the value, when you're reading out of a text box, this is a property of a text box. And so now what we can do, I'm gonna do a console.log, and I'll do a little template string, and I'll say the miles variable holds miles driven, and the gallons used holds gallons used. Okay, so I'm not really doing anything with these variables yet. I just want to make sure that they're holding the numbers that I think they're holding. And again, I'm going to open up the console and say 10 and 5. Click the button. The miles variable holds 10. The gallons used holds 5, which is what I would expect. So we're looking good. Let mpg equals miles driven divided by gallons used. And let's have a if you remember the output tag in HTML, if I can type, here's the output tag, and it just wasn't. You're supposed to, the idea behind the output is it's supposed to take the result of some JavaScript calculation. So we'll just use output with an ID of result. And we'll do result dot enter HTML property. Now notice when you're taking a value out of a text box, you use the value. When you're putting something in between a tag, like a paragraph or an output tag, we use inner HTML. And here I'll use my template literal and say driving this many miles and using this many gallons will give you this many mile per G, And we learned since it's a number, we can round it to 2 decimal places. Okay, so kind of an updated, miles per gallon demo here. So if I drove 10 miles and 5 gallons, 2 miles per gallon. Now, don't know if you guys are still with me, but your homework assignment that I'm going to give is to basically code this, an updated version of miles per gallon and an updated version of test scores, okay, that doesn't use prompts but instead uses text boxes and uses Bootstrap. Okay, so if you're with me this long into a lecture, because we're hours in, you know exactly where to find at least the first answer to your homework, because I just demoed it. Are you with me, or did I lose you?
I'm with you.
This is good. Amel, did I lose you?
No, sir.
All right. Perfect. Okay. So all you're going to be doing is rebuilding miles per gallon with Bootstrap and with template strings and text boxes instead of prompts and document rights. Okay. I'm going to make the Word document available to you, but it's a long first lecture, but hopefully you learned a lot. I mean, what are your guys' initial thoughts?
I'm kind of seeing like a lot of like C sharp, like features.
Yeah. So, was C# first language for you there, John?
Yeah.
Yeah, and I think it was the same for ML. So it's exactly right. I mean, learning your second language is always going to be easier than learning your first, and you're going to see a lot of features. You're right, across all these languages, for loops and if statements and all these kinds of things. Amel, you were saying something?
Oh, I was just piggybacking on what John said. It seems very similar to C#.
Yeah, good. All right, I'm going to stop the recording.